Hey guys, this recording is for our example 5 and the last example in your 10.7 notes, okay? So we did a couple, I think a couple parts already, but because I'm recording for the entire example, I'm just going to start over. Hopefully this is okay with you. Suppose that Jim hit the golf ball with an initial velocity of 150 feet per second at an angle of 30 degrees to the horizontal. Find parametric equations that describe the position of the ball as a function. So if you guys remember, I gave you the projectile motion in class. Okay, let me just write that right here. X equals v subscript of 0 times cosine of theta times t. Then y equals negative 1/2 g times t squared plus v subscript of 0 times sine of theta times t plus h. Okay, and we talked about g being the gravity, and it can be two different units of measurement, 32 feet per second square if you are in feet, or if you are in meters, then 9.8 meter per second square. So when we did this, we talked about using these two for example 5. A, find parametric equations that describe the motion of the ball as a function. So I'm going to use both of them. Here we go. X equals, we know what v subscript of 0 is. That's your initial velocity of 150 times cosine of theta. Actually, let me fill in theta because theta has to be 30. Okay, so theta is 30 degrees. And then all of this is going to multiply to t. And we have y equals negative 1/2. Your initial velocity, because we are in feet, I'm going to be using 32. And now we are going to multiply to t squared plus our initial velocity is 150 times sine. Our angle is 30 degrees. And then all of that's times t. Now let's simplify. So x equal to 150 cosine of 30 degrees is going to be rad 3/2 times t. Let's simplify some more. X equals 75 rad 3 times t. Then over here, we're going to simplify for y. 32 negative half, that's be a negative 16 t squared. And plus 150 times sine of 30 degrees is going to be 1/2 times t. Let's simplify slightly more. So now I'm going to have negative 16t squared. Half of 150 is going to be 75 times t. I'm going to box up both because I need a parametric equation, and I need both x equals and y equals all in time of t. How long was the golf ball in the air for? How long means time. Okay, in the air means the height of that. So I'm going to take y, I'm going to set it equals to 0. So y is going to tell me how high it is, and I'm looking for how high it is in the ball, but I'm really looking for the time. Okay, so I'm going to take y equals and set it equals to 0. So I'm going to factor out your t. So now we have a negative 16t plus 75. I'm going to take each factor, and I will set it equal to 0. So negative 16t plus 75 equals 0. Negative 16t equals to negative 75. T equals 75 over 16, or about, what was it, 4.7? Okay. And let me see what the unit of t was. T is in seconds. Okay, so the ball was in the air for about 4 seconds. Okay. Now we are going to complete C. When was the ball at its maximum height? Okay, so when indicates time. So if you know this is going to be a parabola, so we can do this two ways. We can do the height is 0 at two different time intervals. When it is at initial, which is 0, or at the end when it lands, which is 4.7. Well, from 0 to 4.7 is a total of 4.7 seconds. Its maximum height has to be in the middle if we are talking about a parabola. So we can take 4.7, okay, and we can divide that by 2. If we take 4.7 and we divide that by 2, we are now approximating that the maximum height has to be at about, because we are approximating all of these, at about 2.32, okay? Now that's your time, okay? Now let's look at what that means. I'm really looking for the height. So I'm going to take y and I'm going to substitute in 2.35, okay? So y equals, what was y equals? Negative 16t squared plus 75t. That was our equation before. Now by substitute in time, because we found time, at 2.35. So y equals negative 16, 2.35 squared plus 75 times 2.35. With my friendly calculator, let's see what I can come up with. 2.35 squared times negative 16 plus 75 times 2.35. I have an answer of 87.89. Can you tell me if that's right? Can you double check my basic math, please? Okay. Okay, so let's look at the unit of time again. The unit of time was second, and we are in feet. Okay, so let's go back. And this is in feet, and then this is time, so in seconds. So let's write our answer. The maximum height is, because it says what is, right? The maximum height is at 87.89 feet. What time did we reach a maximum height? Well, that sounds really ugly. At about 2.35 seconds. Okay. That is not really nicely worded. Okay. I think I would totally rewrite that, but since I've already written here, I'm just going to box it up. I would probably write that as at about 2.35 seconds, the ball reaches a maximum height of 87.89. I think that sounded a lot better than what I have written down. Sorry. D, determine the distance that the ball traveled. Okay, distance, horizontal distance is x, and our equation for x from earlier is x equals 75 rad 3t. Okay, and we knew t, remember, t was at 0 or t was at 4.7. Okay, so the total distance that it traveled is when it landed, which is here. Okay, it landed at 4.7 seconds. So I'm just going to plug in 4.7. So x equals 75 rad 3 times 4.7. So let me see what my friendly calculator has in store for me. So 75 times radical 3 times 4.7. My friendly calculator tells me that I have about 610.55 feet. Okay, so the ball traveled about 610.55 feet. All right, let's do E. Using a graphing calculator, simulate the motion of the golf ball by simultaneously graphing the equation found in part A. That means you had x equals 75 radical 3 t and y equals negative 16. Let me see what it was. Negative 16 t squared plus 75. Okay. When you go into calculator, make sure you change it to a key so you can see the motion, the movement of the ball. Okay, so this is really on your own, and see how fun it is. Okay, all right. you can hit pause until you have gotten a chance to draw it out on your calculator. Last example in our 10.7. Tanya, who is a long-distance runner, runs at an average speed of 8 miles per hour. 2 hours after Tanya leaves your house, you leave in your car. Hopefully you can drive and follow the same route. If you can't drive, then you might get a ticket, so don't do it. If your average speed is 40 miles per hour, how long will it be before you catch up to Tanya? Use a simulation of the two motions to verify your answer. That means at some point I want you to do it in your calculator, okay? And that will be on your own because I can't show you, well actually I don't know how to show you this on my Surface Pro using a calculator. So I would just trust you that you are doing your part on this piece. That's on your own, okay? So let's talk about Tanya. She's a runner. I am totally not a runner. She's a runner and she has a rate, an average speed of 8 miles per hour. So that's horizontal distance. I'm gonna use X. Okay, so I'm gonna have Tanya and I'm gonna have you in a car. 4 wheels. All right. So 2 equations. Tanya has a rate of 8 miles for every hour. So our time is going to be in hours, okay? So T equals hours. Now, you in a car has a rate of 40 miles per hour, but you leave 2 hours after Tanya. So it's gonna be T minus 2. Then from here, because we're writing in parametric, I also need y. So y1 equals and y2 equals. Now let me tell you about this y. Y is a horizontal distance, okay? So for this particular problem, y doesn't matter as much. And let me tell you why. Y tells me that you are on the road, horizontal, X is horizontal, Y is the height, my bad. Y is the height. Normally, the car and Tanya should be driving on the same height, pretty much, okay? On the surface road, whatever the height is. But because you're gonna be putting this on the calculator, you can give Y any value it wants, that you want to give it, as long as the Y values are parallel. Okay, as long as the Y values are parallel, it doesn't really matter the Y, okay? So it has to be parallel and it has to be, because it's showing how high it is from the ground, you can give it 0 and 2 or 0 and 5 or 1 and 20. It doesn't really matter as long as these are parallel. And it should be a constant value because we're talking about the surface, okay, the road. So now that you have 2 equations, we have to see how long it's going to take for you to catch up, okay? Well, catch up, meaning that you have to be equal. So I'm going to take 8t, you have to meet up, right, to catch up. So 8t equals 40, 40 times t minus 2. We're going to distribute 40 times t minus 80. And from here, we are going to move the 40 from both sides. So that's negative 32t equals to negative 80. Divide both sides by negative 32. So t is going to be 2.5 hours using my friendly calculator. Well, that's what t is, okay? And t means the time for Tanya. But it wants to know, when will you catch up? Remember, you left 2 hours later. So you will catch up with Tanya in half an hour or 30 minutes. Okay, it doesn't really matter what unit you give for the time, as long as they are equivalent. Okay, this is the end of our 10.7. I will see you next time and study for your test.